this is Professor Zawolo. Today we're going to begin the last of the three of our discussion on the mensuration section of the West African Examination, Senior Certificate School Examination, Mathematics for Liberian Schools. In this videos, we're going to cover the sections on volumes. We're going to define the volume of several kinds of solids, which you see here listed. And we're going to be computing the volumes of similar solids. Now, to do any work in this whole section, we have always stressed the importance of formulas and an appreciation of the figure or solids that you want to find. So the first solid we are dealing with is the cube. So what is a cube? A cube is a three-dimensional figure with all sides equal. So in this here's a cube we have kind of sketched here. So in this cube, all sides of this cube, all three dimensions are the same. So that's why the volume of a cube is going to be equal to S cubed. The next figure we have is what is most often referred to as a rectangular solid or a cuboid. So in this, the structure is called rectangular solid because it's kind of structured like a rectangle. So you have certain sides that are equal. So here we can call this side the length, this is the width, and this is the height. And that is why the volume is the product of those three dimensions. And then we have a cylinder, which looks like this, have a circular bottom or top. And then we have this piece from the center of it to the corner of it, we call that the radius. And the distance between the tops and the bottom is called the height. And so we have a formula for the volume of a cylinder. Let's look at other shapes and other figures. Then we have the right pyramid. So for the right pyramid, it's a pyramid, so like this. So basically, it has a base. This is the base B. That is rectangular in shape. So you normally find the length by the width, or you can use a small b times the height, okay, or the base times the length, and the height is the distance from the top of the. The height is this distance. Then we have a sphere, which is sort of like a ball-like figure, circular-like figure, like the globe. So this is radius, that's for a sphere. And then we have a cone, which is shaped like this. Okay. Again, we have a radius, and then we have the height. All right. Next one, let's look at some other figures again. Okay, now, well, those are the ones that we have represented here. So let's go back. So that was the last of the shape that we have represented. 6 basic formulas we have to do. Just know that the B here is basically the area of the base. It's not just a base length. It's the area, uppercase B. So here we have a circular cylinder. Now, it's kind of customary to say circular cylinder. All right. A circular cylinder 20 meters long. That means the height is 28 meters. And the diameter of 4 meters. Now, before we move along, let's go back to a relationship between the diameter and the radius. Now, we understand the diameter is equal to what? 2 times the radius. So the radius would be the diameter divided by what? 2. So in this case, it's going to be 4 divided by 2, and that's going to be 2 what? Centimeters. So now with all the information we need, and the formula for a cylinder is going to be what? Pi r squared h. We can substitute and find the volume of our cylinder. Let's do that. So what we have now is V equals to pi, and we are told to use 22 over 7 as pi, times the radius, which is 2 squared, times the height, which is 28. Sorry, I wrote 22 over 2. It's actually 22 over 7. And what we have here is 22 times 2 squared is 4 times 28 over 7. Now let's do some fast calculation here. We can divide 7 by itself one time, and 7 into 28 is going to go 4 times. And so we have basically, we can do 4 times 22, that's going to be 88 times 4, and that's going to be 2. 4 times 8 is 32 plus 3, that's going to be what, 352? Correct. 352, 4 times 8 is plus 2, carry 3, 4 times 8 is 32 plus 3, that's 52. Let's, so that would be the volume in cubic meters. Remember, volumes will always be given in dimension of cubic meters. Let's go to number 2. So here we have a cone. So that's a shape like this. We've been given here that the diameter of this cone is going to be 4 centimeters. So we know that the radius will be diameter divided by 2. So that's going to be 4 divided by 2. So that's going to be 2 centimeters. So that's another information we have. And we've been told that the height h here is what? 7 centimeters. So what's the formula for the volume of the cone? The volume of the cone is given by 1 over 3 pi r squared what? H. So let's go, we can write it like this. Pi is 22 over 7. Radius is 2 squared. The height is 7. So this seems to be fairly easy, right? So we can cancel this 7 with this 7. And what we have is 22. 2 squared is what? 4. So we have 22 times 4. That's going to be 88 centimeters what? Cube. Right? So, oh, we got that. Let's do number 3. Very simple and easy process. The hardest part is understanding. So now we have to find the area of a square pyramid. So that means the base area is a square. And here we are told that it has dimension 10 yards. So that means each side of the base is 10 yards. So remember that the volume of a pyramid is given by B times 8. Now, B in this problem is actually the base area. Since we have a square, to find the area of the base area, it would just be the side squared. So B for us, each side is 10. It will just be 10 times 10. And we're going to have 100 yards. Where the volume is B base times height over 3. Sorry. Now, we know the height has been given to us to be 6 yards. So putting it together, our volume will be equal to the base area, which is 100 square yards, times the height, which is 6 yards, divided by 3. So you have 600 divided by 3. You're going to have 200 cubic yards. Okay? Good.
Yes.
Now, say a rectangular tank is 50 centimeters long, 40 centimeters wide, and 60 centimeters. How many liters of water can it hold? Look, 1,000 centimeters cube is equal to 1 liter. So we have to find the volume, and then we have to divide it by 1,000 to be able to convert it to liters. So, well, this is a rectangular, it's a cuboid, a rectangular solid. So if we draw this, okay, so we say it has a length of 50 centimeters, so there's going to be 50. It has a width of 40 centimeters, so there's going to be 40, and 60 centimeters high, so that's deep. So that's what we should put a dBA. So that's going to be 60. So to find the volume of a figure like this is length by width times height. And that's going to be 60 by 40 by 50. Now how do you multiply this? Count the zeros. 1, 2, 3. 5 times 4 is 20. 6 times 20 is 120. So we have 12,000. And then to convert this, 12,000 centimeters cubic centimeters. So we must convert this to liters. So we must divide this by, since 1 liter is equal to 1,000 cubic centimeters, and we have 12,000 cubic centimeters, and we want to know how many liters, we can just cross multiply. We say x will be given by 1,000x will be equal to 12,000. Divide both sides by 12,000, 1,000. Cancel. So x will be equal to 12 liters. Very simple, easy process. So a rectangular tank. Oh boy, it kind of so but let's see, because I see rectangular tank in here. Then I see a cylindrical tank. Oh, so perhaps this is a problem where we're going to be comparing things. So let's see. The rectangular tank, 82 centimeters long, 37 centimeters wide, and 75 centimeters deep, has the same volume. So they have a rectangular tank, the volume rectangular solid, is equal to the volume of a cylinder. Okay? Now, what do we know of a rectangular? We know the length to be 82. We know the width to be 37. We know the height or the depth to be 75. So we have everything that it takes to find the volume of the rectangular solid. Do we have everything it takes to find the volume of the cylindrical tank? Let's see. For the cylindrical tank, we have the radius to be 30 centimeters. Do we know the height? No. That's what they want us to find. So how can we proceed? We can proceed by finding the volume of a rectangular tank. And that volume will be equal to the volume of the solid. And then we're going to set that equal to the formula for the volume of the cylinder and then be able to find R. So let's find the volume of our rectangular tank. So let's do V. So to do that, we're going to multiply 82 by 37 by 75, and our result will be in cubic centimeters. So let's do that multiplication off here with our calculator. So what we have is 82 by 37 by 75, and that gives us 22750 centimeters cubed. Now, let's go ahead now and find and use the volume for a cylinder. What's the formula for the volume of a cylinder? It's equal to what? Pi r squared h. Okay, so now that this volume of the rectangular tank will be equal to that, so I'm going to write 22750 is equal to 22 over 7 for pi times the radius, which we don't know, times the height, which is what? 30 centimeters times the radius what? Squared. So how do we do this? We'll multiply to get the radius. The radius is going to be basically the product of 7 by 22755 0 divided by the product of 22 and 30. This will give us the radius squared. So let's do that multiplication. Let's do this computation over there. So we have 7 So we have 7 This gives us a value of approximately and then we must find the square root of that. So our radius here would be approximately 49 centimeters. So that's good. Let's move on to the next problem we're getting. Now it says find the volumes in liters of a cylinder drum of diameter 28 centimeters and height 50 centimeters. Remember, 1,000 centimeter cube is equal to what? 1 liters, right? So we're going to use that conversion rate. So first, let's find the volume of this in centimeters. So we have a cylinder drum. So we say V is a cylinder. So we pi r squared h. So we're going to use 22 over 7 for pi. Our radius here is going to be 14. And the reason our radius is 14 is because of the diameter divided by 2. 28 divided by 2 is going to be 14. And so the radius squared times our height. And our height in this problem is 50 centimeters. So let's multiply this and find our answer. So we have our volume to be 30,000 centimeters, cubic centimeters. Well, we've already done on this video our conversion. So if that is 30,000 cubic centimeters, to find the number of liters, all we have to do is to divide 30,000 by 1,000, which gave us an answer of what? 30 liters. Okay, let's move on to the next one. The dimension of a cuboid are 20 centimeters, 30 centimeters, and 60 centimeters. Find the length of the longest stick. Well, this is a formula that we did not use, but basically we have to find that like a hypotenuse. So let me draw it and show you how simple and easy this process is. So what we want to find is basically the longest stick will be the one that can, the longest, this is this dimension that we're trying to find. And how do we find that? By rule, that is going to be given by the square root of the length plus the width plus the height squared, which we can find in here by doing 20 square plus 30 square plus 60 square and taking the square root of that. So let's see what we have. 20 square would be 400, 30 square would be 600, and 60 square, 30 square would be 900. I'm sorry. 30 square is 900, and 60 square 3,600. So let's add that up. Oh, I'm sorry. Let me rewrite this expression here. So 400 plus 900 plus 3,600, and from what I'm seeing, this is going to give me 4,900, and that is going to give me square root to be 70 what? 7 meters. Okay. Now we have a pyramid that has a square base. So instead of drawing the pyramid, what I want to do is to draw the base. And I'm told that the diagonal, if the diagonal of the base is 12, square root of 2. So this is 12 square root of 2. So if it's a square, that means I have 90, 45, 45. So I have a 45, 45, 45, 90 triangle. So these two sides are going to be equal. So how do I find that? I would know the relationship is S, and this is S square root of what? 2. So basically, what I'm seeing here that for this that I have, I can say S, and my hypotenuse in this case is 12 square root of 2. So I can equate these two quantities to solve for S. So I have S square root of 2 is equal to 12 square root of 2. And so square root of 2 and square root of 2, S would be basically equal to what? 12. Now you could also find this by using the Pythagorean theorem. Alright, so now S is 12. So I can find B, the area of the square base, which is 12 times 12. And that will give me 144. The volume of our pyramid will be given by B times the height over 3. And now we found B to be 144 centimeters square, because I want to distinguish this from being B, like a base length, times the height, which in this problem happens to be 8 centimeters, divided by 3, and our answer will be cubic centimeters. So we just need to do that computation here. 144 in times 144 times 144. That's going to be 20. Which is going to be equal to 304 centimeters cubed. (384 centimeters cubed). Again, thank you, and this has been the last in a series of 3 videos covering the mensuration area, mensuration section of the West African examination test. It's kind of formula focused. So one of the good things is to go over your basic formulas for finding the areas, finding the volumes. Also go over the basic concepts of trigonometric ratios, special right triangles, Pythagorean theorem, using the distance formula, using the midpoint formula, and you should be fine. Thank you.